We're going to look at relations and starting off in particular with domain and range. The domain and range, well, you'll see this many, many times, so let's focus on what they mean. The domain are the X values in a relationship, and the range are the Y values. So X values, Y values. In fact, if we take something like Y equals 2X minus 5, that equation, the X values are, when you put those numbers in there, you think of them as an input. You input that number, and then you do things to it. In this case, you multiply by 2 and subtract by 5, and you get a Y value, which is the output. So an input and an output is how you think about this. Sometimes in earlier years, you learn about them called function machines. In this case, it's a relation. We can look at functions next section. But if you put in something for the X, you do these things to it. So you put in the X, then you multiply by 2, you get an answer, and then you subtract 5 from that answer. So it's like doing these steps. Put in the number for the X, multiply by the 2, and then subtract 5. And as a result, you get a Y as an answer. And that Y is the range. And also we think of this as an independent variable. It's an independent variable because you can choose what to put into it. The other one, though, is dependent. You do not choose. In other words, the dependent one comes from the independent one. Your choice here, but not your choice here. So your choice, but this one is the result. All right, now back to about the domain and range. I am going to graph a particular type of equation. And I'm going to graph Y equals, let's go over here. Let's do X squared plus 2. Okay. What that's going to be is a, let's see. Yes, I want to go up 2. Now, I actually want to change it slightly, so hold on. Let's taking it through here. Y equals X plus 1 squared plus 2. What that's going to be is an equation. That equation is a parabola that looks like this. All right. It starts here. That's because of the plus 1. We actually use the opposite sign or minus 1 for the X value for this. And it goes up 2. So this point is -1, 2, and that's called the vertex of the problem. But that's not my point of showing you this. My point of showing you this is that the domain are the X values. So when you look at this and you move along here, all the X values, like right now, this is a good X value. Every point along here, all of these X values are all good. And all along here, the X values are good. But this parabola goes forever and forever and forever. In fact, it's going to go like this, and it's going to go like this, and it's going to go forever. It looks like it's going high, but it's never going straight up. It's always going a little bit to the side, which means that ultimately all of these X's all the way out to infinity are going to be used. And all of these going up to infinity are going to be used. So the domain is all of the numbers on the graph that are X's going both ways, which means it's all real numbers. All real numbers is the domain. For the range, we have a different thing. The range are the Y values. And for the Y values, notice that the first Y value is at 2, and then it goes up 2.1, 2.2, 3, 5, 7, 85 million. It goes up and up and up and up and up forever. But none of these are being used. We're not using 1, we're not using 0, we're not using -1, we're not using -1.5 or anything down here. It's almost as if that it starts here and goes up and never goes below it, which is exactly what happens. So the range is going to be all of the numbers, or that the y values that can be used, all these y values that are greater than or equal to the number 2. So that's the domain and range here. Sometimes it's every number, like you see with the x values here going out both ways. And sometimes it's only from a particular y value up or down. And sometimes that can happen with the x's too. But in this case, you see 2 possibilities: all real numbers or only some numbers, which will show with an inequality or an inequality sign. It's all the ones that are greater than 2, including 2. Now let's take a look at different representations of a relation. This comes from the textbook, as I mentioned here, top of page 41. And so you can represent a relationship as a set of ordered pairs, or in a table, like we see here, or on a graph, just simple dots, these are the same ones, or in mapping, where you match up, like go back to the table or even to the ordered pair. The 1 and the 2 match up, therefore the 1 and the 2, the 1 in the domain matches the 2 in the range. The -2 in the domain matches with the 4, and the 0 matches with the -3. Sometimes a line might go diagonal. That's acceptable. There's nothing wrong with it. Okay. So here it tells you the x values are members of the domain and the y values are members of the range for a relation. And so the domain is the numbers, and notice these are in numerical order from smallest to last. I'll put a D here. And these ones for the range are the y values in order from smallest to largest. So this, you need to know these names. You need to be able to say and write on my test: ordered pairs, table, graph, mapping. Sometimes show examples or recognize what they are. So let's take a look here at identifying independent and dependent variables. Now, this comes from the textbook from example 2, as it says here, and I thought it was worth it to copy this to go over how to determine that. We're looking for independent and dependent variables. So in this example, the dance committee's selling tickets. The more tickets they sell, the greater the amount of money that they can spend. So we have 2 things. We have tickets and we have money. So let's think about which ones happens here. You're selling tickets. So when you get done selling tickets, then you have an amount of money. The amount, let's think about which one depends on the others. Do the number of tickets depend upon the amount of money, or does the amount of money depend on the number of tickets? Common sense here says that the money depends upon the tickets. That means that the money is the dependent variable, and the tickets are independent because it's what causes the dependency, the amount of money. So the tickets, you sell them, however many you decide. You may want to sell more, so it may not be fully your choice, but still that's the independent thing. You have to get that number to start the process. Then that results in the amount of money that you get, which would be your dependent variable. So the independent variable here is the number of tickets. The dependent variable is the money. So they say that here, tickets sold is the independent variable, and then the money is dependent because it depends on the number of tickets sold. That's the thinking to have. Now we look at this next one. The average price of the movies has steadily increased over time. So you have price and you have time. Right, so price and time. Well, this tells you time is independent because it's not affected by the cost. So the price doesn't affect how many years, how many months. how often people have gone. Actually, it does. Price it says how many, but it does. Let me rephrase that here. The time doesn't make the price go up or down. All right, so I am re-saying, okay, let me just follow what they say here. Time is the independent value because it's unaffected, but the price is affected by time. Okay? Because what this is saying, the average price has steadily increased over time. Let's make it like a little graph. Say 10 years from now, 9 years from now, I'll call it 1, 2, number of years here. 9. Okay, so actually, and then if I did price going up, say, I probably have to go like 10 years. If I did some research and saw it, I could say, let's say it was $8, $9, $10, 11, 12. I think it's up to $15 in cases. So we see something that's sort of like this. Not exactly. Sometimes it goes up a little, down a little more. Usually it's always up though. Though I've seen some prices go lower recently. Ticket movie theaters are trying to get people to come back to the theaters and they haven't. So they're trying to temporarily, I think, lower prices. But generally it's an upward trend here. But the time does not depend on the price. However, the price does. As the time goes up, as T goes up, the P goes up also. Price goes up. So you have to always be thinking on these, which one depends on the other. The time does not depend on the price, but the price to some extent really depends on the time, more so than the other way around. One example that I'll consider is this. Air pressure inside a tire increases with the temperature. So the question in here is does the air pressure cause the temperature, or does the temperature cause the air pressure? So when they say increases with the temperature, that's a way of saying that, well, they both go up. Yes, they both go up, but the air pressure doesn't change the temperature of the tire, but the temperature will make the air pressure go up or down. If I'm right, I think that as the temperature is higher, as it gets hotter, that I think the air pressure is increased. There's more pressure inside the tire. My physics is not as strong as my math, so I'm not certain exactly how it works. But I would say that if the air pressure is increasing, that does not necessarily mean the temperature is also going to increase. So that means that the independent variable is the temperature. And the dependent variable is air pressure. Because the temperature causes the air pressure, or the air pressure results from the temperature. That's how you need to think about these, is which one causes the other one. Which one is independent, not affected by the other variable, but which one of them is affected by the other variable. I hope that helps with some of these things you see in this section on relations. Thank you for watching and listening.